Kia ora, Year 12 and 13. This is the first three parts of question 2 from the 2014 paper. So these questions are two achieved questions and a merit question, so they should feel pretty easy. Have a go at them before I work through the answers. Okay, the first one is a simple quadratic. We've got x squared minus 4x plus 16 equals 0. I'm going to do this using completing the square. I'm making that decision because this is an even numbered coefficient with the x. So I put a little box around that and off we go. So we get x minus 2 squared minus 4 plus 16 equals 0. Right, x minus 2 squared, subtract this from both sides, so that equals negative 12. Take the square root of both sides and I get plus or minus root negative 12 here. So x is equal to 2 plus or minus root 12i. Now you could leave your answer like that. Strictly speaking, that's what they're looking for, right? But that looks unfinished to me because I've got a perfect square hiding in here. So we can write that as 2 plus or minus 2 root 3i. Okay, so that's part A done. Let's go on to part 2b. Okay, so w is equal to 2 cis pi on 3. We're asked to find w to the power of 4. So we're going to use the Moivre's theorem to do that. And that tells me that the modulus is 2 to the power of 4. And the argument will be 4 pi on 3. And so that's 16. So this is 4 pi on 3. If you are in my class and you're watching this and it's the school holidays, we haven't done this yet, so please don't freak out. Right, so the last thing we need to do is to apply the definition here. So this equals 16 cos of 4 pi on 3. It's going to give me the real part of my complex number plus I sine 4 pi on 3. Right, as soon as you look at these, you need to be thinking about two things. Special triangles. Right, so there's pi on 3, 1, root 3, and 2. And we're thinking, where is pi on 3, 4 pi on 3, as an angle? So let's look at that. There's my 0 line. That's pi. So 4 pi on 3 is down here. And we can see from looking that the x value of whatever number I've got is going to be negative, and the y value is going to be negative as well. Right, some of you liked this little memorization thing, which is for which trig functions have got a positive in which quadrant. All it really does is what your brain will tell you anyway, which is that in this quadrant here, both the x and y are positive. So that means sine and cos are going to be positive. Tan will also be positive because tan is sine over cos, and that's positive over positive here, and so on, right? For example, down here, cosine, which is where my x values come from, is going to be positive, but sine is negative, right? Because that's the link up with the y values. So here, I'm going to get 16 times, well, cos of negative 4 pi on 3, cos of 4 pi on 3 is equal to 1/2. So negative 1/2 here, plus I, sine of 4 pi on 3 will be negative root 3 on 2. Now I'm going to squeeze the final answer in here. So that equals negative 8 minus 8 root 3 pi. Okay, so that's that one done. Right, on to part C. Right, so w minus equals 2 minus 3i is a solution of this equation. So what do we know? Well, we know that a, this coefficient, is real and we have to figure it out. We know that it's a cubic, so it must have 3 roots or solutions. And we know that if this is one of them, then its conjugate, w bar, is equal to 2 plus 3i, is also a solution. So what we can do with that is we can figure out what do we get when we expand this. W minus the first solution times w minus the second solution. Right, when you do this, be really careful. This is a minus. Okay, your plus goes in here. Right, so just have a think about that. It's like if we knew that 2 and 4 were solutions of something easier, we'd have x minus 2 and x minus 4, right? So there's a minus there and a minus there. So we're going to expand this out, and you should do quite a few of these for practice because you'll start to get quite fast at them. But I'm going to do this one slowly, okay? So we're going to get w squared here, and then I'm going to do my other real bit next. So I'm going to get this pattern plus, because it's a minus times a minus, 2 minus 3i, 2 plus 3i. Now we've done this in class, right, when we looked at how come the conjugate is also a solution. And then I'm going to have this one times this, so minus 2 minus 3i w. And then I'm going to have this one times this, and that'll give me my other w coefficient. Right, and we're going to see that we lose our imaginary parts of the numbers here. So that simplifies when we expand to w squared, right, that's that one there, right here, minus 2w plus 3i minus another 2w minus 3i. So that goes to minus 4w. And this last bit here becomes plus 2 squared. So 2 squared is not 2. 2 squared is 4. This and this and this and this go, right, because they're conjugates. Minus 3i times plus 3i gives me minus 9i squared, which is plus 9. So what have we got? Well, we've got this quadratic is one factor of that equation that we're looking at. Right, so that's our first, that's the messiest step when you're solving these problems, is work that one out. And now on the next slide, we're going to look at how I can figure out the other linear factor. Okay, so we're trying to solve this. 3w cubed minus 14w squared plus aw minus 26 equals 0. So we're looking for some different things here. We're looking for all of the solutions, right? And we've got 2 of them. We still need the third. And we're looking for the value of a. But what we can write down now is that w squared minus 4w plus 13 times something equals 0. So we can start matching up coefficients, right? And it's really easy now. We need to have something that's going to multiply to give us 3w cubed. So here we're going to put 3w. We also need to have something that's going to multiply to give us negative 26. So this must be negative 2. Now we can check that it's going to work to give me negative 14w. Well, here we've got minus 4w times 3w, so that's minus 12w squared. And here we've got minus another 2w squared. So it looks good. So you can see the first thing that falls out of this is my last solution. 3w minus 2 equals 0. So w equals, hang on, 3w minus 2? Yeah, so w equals 2/3. And I can work out the value of a. Here's how I do that. I've got 13 times 3w. And here I've got minus 2 times negative 4w, so that's plus 8w, is 47w. So my whole thing expands to give me 3w cubed minus 14w squared plus 47w minus 26. A equals 47. Right, so I'd like it if we could write out those solutions nicely. So I'm going to do that here. So w equals 2/3, w equals 2 minus 3i, or 2 plus 3i, and they are my solutions. Right, so some minimal amount of beautifully neat communication like that. Alright, so that's a merit question. It seems bad to start with, but actually it's quite an easy pattern to spot what you're doing. If you really don't like this step here of matching up the coefficients, you could do long division, but it's probably going to be slower. Alright, you can ask me about that if you've got questions. Thanks for watching.